Okay, so today we're going to continue talking about complex polar values. And so we're going to learn about de Moivre's theorem and how to find complex roots. And de Moivre's theorem is going to be about finding the powers of complex numbers. Okay, so we are still given a value for z, and then for any integer n, this is de Moivre's theorem, you can have z to the power of n. That is going to be equal to r to the nth power. And then notice with the theta, you are going to multiply both of those by the value of n. Okay, so once you have that, in example 1, it says find the indicated power using de Moivre's theorem, and in step 1, you are converting that point to polar form. Okay, that is what we did yesterday. So with your polar form, you need to find your r and theta. So I want you to do that for part A. Okay, so convert the 1/2 plus 1/2 I to polar form. Okay, and I know some of you are going to finish that a little bit quicker than others, so if you also want to do step 1 for part B, you can. And then I'll come around, so if you're having some trouble doing that, I can help. You need your value of theta. We're going to simplify r if you need to. Okay, and then just double check your theta. Make sure your theta matches your quadrant. Okay, so theta is going to match whatever quadrant you have there. So for the first one, when you square 1/2, you get 1/4. 1/4 plus 1/4 is 1/2. And then when you take the square root of 1/2, you need to simplify it. Okay, the square root of the numerator over square root of the denominator. Okay, and then Kinley, what'd you get for your r value when you simplified? Yep, root 2 over 2. All right, and then Kristen, for your theta value, what did you get? Great. Okay, so you have the tangent of theta is equal to 1. So your polar form is root 2 over 2 cosine of pi over 4 plus I sine pi over 4. Okay, do you guys have any questions on that first part? Because you need to have your work down there for that. All right, then let's talk about de Moivre's theorem. So in de Moivre's theorem, you're using z to the n equals r to the n cosine of n times theta plus I sine n times theta. So if your r value is root 2 over 2, we're going to do this without our calculator today. And you have the cosine of, in this case, your n value is going to be what? That's your 12. Yep. Okay, so your n value is going to be 12. It's whatever your power is. Okay, so you have z to the 12th equals, okay, and then we're going to multiply 12 times pi over 4. Oh, 12, sorry. Thanks. Okay, so your n value is going to be 12, so you have root 2 over 2 to the 12th, and then 12 times pi over 4. What is 12 times pi over 4 simplify to? 3 pi. So yesterday we left these in polar form. Today we are going to simplify them to binomial form, and that means we are just going to use the unit circle to calculate. Okay, so if you are a visual person and you want to draw out where 3 pi is to help you with those values, you can. You don't have to. Okay, so we know that this is 2 pi, so 3 pi is the same place as what? Pi. Okay, so you have -1, 0. -1 is x, so that's going to correlate to cosine, and then your y is going to correlate to your sine. Okay, so I said we were doing this without our calculator. So when you're doing that, you have 2 to the 12th on the bottom. If you do root 2 to the 12th, okay, think about what happens. You have root 2 times root 2, that's going to happen 12 times. But what's root 2 times root 2? 2. So how many 2's do you have? 6. Okay, because there's going to be a pair. For every pair, it's a 2. And then when you have exponents, what can you do if you have the same base? Subtract. So it's a -6, which means you have 1 over 2 to the 6. Okay, and 1 over, what's 2 to the 5th? 32. So 2 to the 6th is 64. So it's 1 over 64. All right, and then when you plug this in, we said this is going to be -1 plus, this is 0 times I. Okay, you won't have to write in the 0. We're just doing it so you can see what happened here. And then you are going to multiply. Okay, so your solution is -1/64. Okay, so for these, you are going to write your answer in binomial form. You may be thinking, but Miss Whipple, that's not a binomial. That's because your b value is 0. Okay, so binomial form is a plus bi. Okay, and if you have no imaginary term, it can just be this one value here. Okay? All right, so I'm going to have you do part B. Remember that you want your theta to match your quadrant. Okay, so I want you to do part B. You're going to find your polar form. Okay, so in step 1, Gabe, what'd you get for your R value? 2. Okay, so just make sure that when you guys are plugging in those values, you're only plugging in the A and the B. So your A is -1, your B is -√3. Okay, so this is 1 plus 3. That's where you're getting the value of 2. Okay, and then Nina, what'd you get for your theta value here? Okay, so when you have the tangent of √3 in quadrant 1, where is it √3? At pi over 3. Yep. Okay, so this has to be in what quadrant? So a negative is going to be in Q3. So sometimes what I do is I start with, oh, I know it's going to be here in quadrant 1. So to get to the place in this quadrant, you just have to do what? Add pi. Yep. So what's your theta value going to be? 4 pi over 3. Okay, so then your polar form is 2 cosine of 4 pi over 3 plus I sine 4 pi over 3. Okay, so now when we go to de Moivre's theorem, we just look and see what our power is. So if our power is 5, we're going to plug that in. So z to the 5th is going to be 2 to the 5th cosine of 5 times 4 pi over 3 plus I sine. And then remember, when you're multiplying fractions, you just multiply your numerators. So this is 20 pi over 3. If you are a visual learner, it does help to do this, okay? I know some of you are more conceptual and you can do that in your head. That's okay too. So think of one time around. One time around is what pi over 3? Yep, 6 pi over 3. So if you go around again, you're at 12 pi over 3. And if you go around again, you're at 18 pi over 3. So when you're getting to 20 pi over 3, here's 19, 20. Okay, which means you're going to be in quadrant 2, so you should have a negative x and you should have a positive y. So a negative, positive. Okay, so I want you to find that point and plug it in if you haven't already. Again, sometimes it helps to write out the point from quadrant 1 and then transform it. Okay, so if we convert it to quadrant 2 here, the 20 pi over 3 should have a negative x and a positive y. That's what you're going to plug in. So you have -1/2 plus √3 over 2i. Okay, and you do have to distribute. When you distribute, you are dividing. If you have values on the outside that can be simplified, you are going to divide them. Okay, so you should have -16 plus 16 √3i, or sometimes people will put the I in front of the root. That's fine too. Okay, but your solution does need to be in binomial form. Okay, when you go to the next side, you're going to see a beautiful, very large formula with a lot of stipulations in it. Okay, I want you to look at those and see what is similar to some of the formulas we've already been working with. We're going to highlight a few of those things together. Okay, so we still have this polar form, your z value, but now we are using this to find roots. Remember that when you have a root, you can write it as a fraction. 1 over n, that's how you can write a root as a power. And so you have 1 over n here, okay? N also appears in the denominator for cosine and sine. Okay, we have our theta value, we have our r value, and then we also have this value of k. So we're going to be plugging in values for k. It says 0, 1, 2, up to n minus 1. That's just another way to say the number before n. Okay, so if n is 4, 4 minus 1, 3. If n is 10, 9. Don't worry, we won't go up that far because that would be a lot of work. So we are going to be using this formula here to find the roots. So you're going to find the indicated roots, and then we are going to graph them on the complex plane. You did a little bit of that in your 8.3 intro packet, graphing on the complex plane. And for A, it says we are going to find the 6th roots of negative 729. So if you're finding the 6 roots, your n value is going to be 6. Okay, you are going to write this in polar form. Whenever you are writing this in polar form, remember, based on our information box yesterday, when you're writing it in polar form, your r value is positive, and your argument of theta is in between 0 and 2 pi. Okay, so if you just have negative 729, this is your point, negative 729, 0. Okay, we did something almost exactly like that yesterday, so I want you to find your polar form for that. Yesterday we did negative 20, 0, so this is going to be really, really similar. All right, so you guys can check yours with mine. R is 729. Again, it has to be positive. Remember, all you're doing here, if this is squared, the square root is undoing that, and you're taking the positive form. Okay, when tangent is 0, you have to decide, is it 0 or pi? It's all based on where this point is. So if it's a negative, it's on the left side, that's going to be pi. Okay, so then you have your polar form. I think it's helpful to write out the general form of the equation because this is what you're going to be plugging your values into. So your W sub k, which is r to the 1 over n, is going to be 729 to the 1 over 6 because your n value is 6. And then you have the cosine of theta. Oh, sorry, I want to plug in theta. What is your theta value? Pi. So we're going to plug that in because we just found it. And then it'll be plus your 2k pi over the value of n. So go ahead and plug that in. Okay, so we're going to plug in the theta, which we found was pi, and then plus, this is 2k pi divided by, your n value is 6, and then the sign is the same thing, pi plus 2k pi over 6. Okay, so this is the general equation that we're going to be plugging values into. Okay, so whatever we find here for the cosine is going to be the same thing in the sine. So when you are generating the roots, you are just going to replace k with the integers starting with 0 and going up to n minus 1. So if our n value is 6, you're going to start with 0 and go up to 5. Okay, and another thing to note is you should have n answers for n roots. So we're trying to find the 6th root, which means we are going to have 6 different solutions that we're going to graph on an imaginary plane. Okay, and then just so you know, this is one of the higher ones. You aren't going to have to do anything above 6. So in the first case, when you're plugging in k is 0, w sub k is now w sub 0. Okay, so you have 729 to the 1/6 power, which is just the cube root of 729. Okay, for one that's that large, I'm fine if you use your calculator for that. And we'll simplify it together. Okay, now it's the cosine of pi plus 2k pi. So if I plug in 0, it's pi plus nothing, so it's just pi over the value of 6. Oh, sorry, it's not. It's 1/6. And guess what the answer is for 729 to the 1/6? 3. Okay, so 729 to the 1/6 is 3, and sometimes I get a little ahead of myself. And that's what we're going to write down in the next step. All right, and then just like we did earlier, when you have this pi over 6, you're going to use your unit circle. Okay, so on your unit circle, think about what your value of pi over 6 is. We're actually going to write it because you're going to be using it over and over again in this. Okay, so at pi over 6, you guys remember what your point is? Yes. Okay, so then when you plug this in, the cosine is root 3 over 2 plus 1/2 times I, and then you just distribute. Okay, so you have 3 root 3 over 2 plus 3/2 I. Okay, and that is your root in binomial form. Okay, so for k equals 1, it's w sub 1 equals, it's always going to be 729 to the 1/6, so we can just start writing 3 in front, that's fine. Okay, and then I want you to plug 1 in for k, write what that's going to be. So use the general form of that equation.
Excuse the interruption. A lunch. We need to do a much better job of cleaning up in the gym tomorrow, or we won't have balls on Friday. So.
All right, so when you plugged in a 1, 2k pi is now just 2 pi. Pi plus 2 pi is going to be 3 pi, and then 3 pi over 6 reduces to what? Yeah, so it's just pi over 2. You guys with me on that? Okay, so once you do that, now you can just find the point at pi over 2. Okay, so you have 0, 1, so we're just going to plug that in. Okay, so you have 0 plus 1i. Okay, so that is going to simplify to 3i. Okay, and now we are going to go to k is equal to 2. So we have w sub 2 equals 3. And then when you're doing this over and over again, you're going to start recognizing these patterns. So if you have 2k pi, 2 times 2 is 4, so you'll have 4 pi. Okay, all of them are over 6 for this one. Okay, and then 5 pi over 6 is in what quadrant? 2. So if it's in quadrant 2, you have a negative root 3 over 2, a positive 1/2. That's what we're going to substitute in. Okay, so at 5 pi over 6, your cosine is negative root 3 over 2 plus 1/2 I. And then don't forget to distribute here. Sometimes I forget that second part. All right, so I want you to do k equals 3, k equals 4, k equals 5. Okay, so I'm going to give you some time right now to calculate those. Okay, if you finish it before I help you graph it, and I do want to help you graph it, you are welcome to start part B. Okay, now that we have those, we are going to graph them. So in order to graph them, we are going to write them as points. Okay, you guys can check yours with me really quick before we do that. So you should have negative 3 root 3 over 2 minus 3 over 2i. W sub 4 is negative 3i. Okay, and then W sub 5 is 3 root 3 over 2 minus 3 over 2i. So you should notice a lot of these are going to have the same decimal. And when we graph them, it is a lot easier to graph them by writing them as points. And when you're graphing on the imaginary plane, the y-axis is the I, the x is the real number. Okay, so for W sub 0, okay, you have 3 root 3 over 2, so we're going to convert that to a decimal. So 3 root 3 divided by 2 is going to round to 2.6. So this is 2.6 plus 3 over 2 is just 1.5. So when you graph that point, you do the real number first and then the I. So you're going to graph 2.6, 1.5. Okay, W sub 1 is just 3i, so that would be 0, 3. Now, if you look at W sub 2, you have the same thing that we had here, it's just a negative. So this is negative 2.6 plus 1.5i. For W sub 3, you have negative 2.6 and minus 1.5i. W sub 4 is negative 3i, and then W sub 5 is 2.6 minus 1.5i. So once you find that first decimal, you're just going to be using that several times. And these are your coordinates that you're going to be plotting. And I am going to plot mine with a pencil because mistakes happen. And then I'm going to tell you what kind of shape it is. And whenever you do your graph of these, it is always going to be this shape. So if I do 2.6, 1.5, here's 1, 2, about 2.5, 1.5. This is your W sub 0. 1, 2, 3, 0, 3. That's your W sub 1. Negative 2.6, 1.5. These are symmetric. So that should happen. And then you have negative 2.6 and negative 1.5. So these are symmetric. Okay, and then for W sub 5, you have the 2.6, 1.5. This is the most common shape that we've been graphing on our polar coordinates. It is a, Cedric, what is it? It's a circle. The shape should be a circle. So do not connect them with hard edges. Okay, every single time it's going to be a circle. Okay, even if there's only 3 points, it won't be a triangle. You're going to have to make the circle. So what I found is that the simplest way for me to get a good looking circle is I do like a dash line first, dash it through. And then I connect them. That looks pretty good. How'd you guys turn out? Good? All right, so for part B, we're going to do the cube roots. Yay, because cube roots means you only have to find how many? 3. Okay, so if it's cube roots, your n value is going to be 3. Okay, so you're going to start by finding your r and your theta. So when you do 4 root 3 squared, think about what's happening there. Okay, so 4 squared, 16. Root 3 squared is 3. Okay, 16 times 3 is 48. 48 plus 16. 64, square root of 64. 8. So that's going to be your r value. Okay, for your tangent, you do b divided by a. So when those cancel out and you have 1 over root 3, remember that you have to rationalize. Okay, and this is a place on our unit circle, but if you ever had a value that wasn't an exact value, what would you do to find theta? Yes, take the inverse. Okay, so this is in quadrant positive, positive, quadrant 1. So your theta value is going to be pi over what? 6. Root 3 over 3 is pi over 6. Root 3 is pi over 3. Okay, so now, again, I find it helpful to write this out so when you're plugging in K, you can see what you're plugging it into. So your R value is 8. It's going to be to the power of 1 over 3. And then you have the cosine of theta, so pi over 6 plus 2 pi k divided by 3. Okay, and then this is I sine of pi over 6 plus 2 pi k divided by 3. Okay, we're going to make sure that you're set with W sub 0, and then I'll give you time to work on the rest, okay? So 8 to the 1/3, what's the cube root of 8? 2. Okay, and then when you plug in 0, it's just pi over 6 divided by 3. We know when you do pi over 6 divided by 3, it's like you're multiplying by 1/3. So that becomes pi over what? 18. So you have the cosine of pi over 18 plus I sine of pi over 18. That is not an exact value on the unit circle, so we're going to leave it in polar form. Okay, and then you are going to want to convert to the binomial form for graphing. Okay, so when you do that, you just want to make sure that you have the cosine and your mode is in radians. Okay, so cosine, not cosine inverse. Okay, and then you can do this all on your calculator. I'm just going to write out this for you so you understand what's going on. So you have the 0.8 ... plus, and really at this point you do want to multiply it by 2 so you get the most exact answer. So it will be 1.97. And then if you do the sine of pi over 18, okay, that you're going to multiply by 2 as well. So just times 2. Okay, so you get 0.35 I. Okay, so you'll have this for your graph. Okay, you can just round to the nearest 100. Okay, so when you're doing this on your own, you don't have to write out this step. You can just do that part in your calculator. Okay, so you're going to find W sub 1 and W sub 2. Okay, when you go to scale it, you're going to see you have a lot of small numbers here. So I scaled mine by 1/2 when we check ours. If you want yours to look like mine, you can scale by 1/2 too. And remember, the shape is always a circle. So when you connect it, that's what I should see. Okay, so you're gonna finish this, and the mandatory turn-in for tomorrow is your note guide. Okay, so you're gonna complete that. Okay, so the only thing that you have to do tonight is finish this, including the graph. Okay, and then I'm going to give you the no penalty assignment. I did change this morning to make it shorter. So if you wrote it down earlier, just know that I took some problems off. So the ones that cover page 1 are 72 through 73, 77 and 78. And then the ones that cover the last 2 pages are 84, 87, and 88. Okay, and I did change that on the calendar as well. Okay, so I'm going to let you finish those.